So we only have cotangent here. Usually cotangent is nice to have it with cosecant, because we know that cotangent actually, there's several things we know. Cotangent squared plus 1 is cosecant squared x. Cotangent x, if you differentiate this, you get minus of cosecant squared x. And cosecant x, okay, if you differentiate that, you get minus cosecant x and cotangent x. So you should have this all memorized if you haven't already done so. So the only one with square here when you differentiate is cotangent, okay? But we need a cosecant when you differentiate that, so we don't have that here. But using this, we can get some cosecant. So let's do that first. So now I'm gonna write these numbers on the integration intervals for now. So I'm gonna write that as cotangent x times by cotangent squared x. I'm going to replace that right there with cosecant squared x minus 1. Okay, cotangent x, you get cosecant squared x minus 1. Okay, so let's distribute that. You get cotangent x cosecant squared x dx minus cotangent x dx. Because this is perfect. If you let that equal to u, that's equal to minus du, right? So if you let that equal to u, okay, let me do it. U equals to cotangent of x, then you get du is equal to minus cosecant squared x. I'm just using exactly this right here, okay? So I can replace that right there with minus du, with u in front. Okay, this right here, you have to think of it as a cosine of x dx over sine of x. Okay, so here I'm going to let v equal to sine of x. You get, so dv is equal to, right? dv is equal to cosine of x dx. So this one right here, if you integrate that, you get minus half of u squared. Okay. Here you can see that you can replace that all with dv, and that's v. So u here is cotangent, so I'm going to replace it with cotangent squared x. This is ln of absolute value of v, which is sine of x. Okay, and that's it, plus constant. So often this is actually something that a lot of people memorize too. The integration of, so what we just did here was cotangent, right? Cotangent of x, we just got to be this, right? Minus ln of sine of x. But if you bring that minus 1 up, you get ln of sine x all reciprocal. So you actually get ln of a cosecant x. So cosecant and cotangent are very tightly, there's a lot of relationship between the two. They're linked together. Okay. So if you have it memorized, and a lot of, if you're looking at an answer key in a book or something, you might actually see this instead. Ln of, right, cosecant x plus c.